Thank you, Mr. Srivastava, and warm welcome to everyone, my friends on the dais and uh, the audience. Uh, as Mrs. Srivastava rightly pointed out, that uh, a deep or deeper exploration. I'll say still deeper, much deeper, maybe even 3,500, 4,000 meters. Uh, can you put the next slide, please? Okay. So when we commence our exploration, uh, we have this exploration triangle. So at the base, you can see it is when you access a new block, uh, what all you do with those blocks. So I've not put this to go into the depths of what exactly is done, but mainly to discuss that at each stage or stage gate of exploration, uh, there is a full cycle economics that we do. The projects team is involved in that. And basically, the idea for that is that everyone is on board, everyone is aware that the resources that exploration team is giving, whether they are exploitable with the technology that is available at that point in time, based on whatever water depths are there for those prospects, leads, plays. So at each stage, it goes under revision, be it at the play or the lead or the prospect stage. At each stage, actually I should mention the bid stage also. At each stage, it goes through revision as the data matures. And of course, the project team is always on board as far as technology development is concerned. So that discussion is always on. Now, when we started exploration some 20 and odd 22 years back, uh, initial years, 4, 5, 6, 7 years, we had a lot of blocks, uh, and we almost covered, and mostly on the East Coast, few on the West Coast, but we almost acquired 100,000 square kilometers of 3D seismic data in those early years. So we have covered the almost all of East Coast, Mahanadi to KG and Kaveri basins. Why I'm sharing you this is there is a lot of data acquired. Now we relinquished a lot of those blocks, but there is always hope in the sense that with new ideas, new minds, and technology development, those same areas can be, looked into again. And we ourselves have, trying to look back even the blocks that we relinquished and going back and see whether a different play can be established, especially taking analog from, world over, for example. I'm not mentioning any discoveries in the recent past, but any analogs that is there in the world basins that can be used as for further inquiry into even the current data sets. Now, when you again start exploration, so you create certain what we call as hero lines. So these are this is just an example of a hero line where you do your study bottoms up. So the crustal architecture, where is your continental crust, where is your proto-oceanic crust, where is your oceanic crust, how the different unconformities are, there on the seismic, how you tie across the basin. So we did this work on the whole of East Coast, and at that point in time, we had phase one of GXT lines, which were pretty good, and then phase two came in much later. So that gave us a good tie all along the East Coast and to develop models. I mean, only issue, I think yesterday some speaker mentioned about, I think Madam Sushma Raut mentioned about, uh, the problem in Indian East Coast is that you don't have luxury of the conjugate margin studies because you don't have data on the Elan Bank or the Antarctica, right? And that is one. The other problem is that you have the 85 is ridge, so volcanics, which basically suppresses any magnetic anomalies that should have been there. Few are there, and people have used them, but still that is a big problem. So what we have to live with is developing models, I mean, basically plate tectonic models. And we know that India moved very fast, I mean, compared to any other continent, India moved pretty fast. There are different theories why it moved fast. It has thinner continental crust overall compared to other, continents and all those things. But basically, it moved fast, so it has different plate tectonic models or setup for east and the west coast. The west coast is very similar, where the Madagascar side you have very less information, very less data. But whatever data is there, and that being a strike slip margin, the west coast of India and the Madagascar. So still, and again infested with basalts. So that creates another problem. So those challenges have to be overcome with technology, with integration of the data going forward. So that is the purpose of this slide. We have been, a deep water player through and through, and most of our discoveries have been in the starting upper slope. So upper slope, mid of slope, lower slope, toe of slope. I mean, discoveries that we have made, they have been in that regime, be it in Mahanadi or even in Kaveri. So Mahanadi Kaveri discoveries, of course, with blocks we relinquished. Now it is with a different player. Hope they do something, add resources, and so why I'm again mentioning this? The projects team gave us a pushback. I mean, whatever we did, I won't give you any numbers, but certain TCF is required in certain water depth. So we had to relinquish Kaveri because it could not be, developed. Mahanadi, we are going through the process, whether we can add more resources, and especially with the OLP 9 coming in, with better, financial regime, we can maybe add resources. It will take time, but Mahanadi discoveries are still, yet to be, exploited as of now, as we speak. One of the things that we kind of worked very hard on since we had these discoveries in upper, mid, and toe of slopes was how the sediments get deposited. Because, although we had 3D seismic data, but 3D has its limitations on, especially if you have thin channels or the, the feeders, as you call it. So how you map it out? Where is the limit of the fan system? So there's a very recent paper, and this basically all this study is done in the lab. So it gives us very kind of a directionally kind of a usable bottoms-up model to understand how the sediments are deposited. So if you are in a kind of upper slope regime, then whether those feeder channels will play havoc with the migratory hydrocarbons, whether it will connected, or whether it will be clay filled during the next transgressive cycle. So all those things can be built up on these kind of a background models. So I found this paper very interesting, and based on your detailed mapping of the slope topography, you can actually find out which areas are more amenable for depositing of sands and how thick the sands can be. I mentioned thickness specifically because we have experienced that as you go deeper, and now we are talking about 3,500 to 4,000 meters of water depth. One is the frequency of the data, that becomes lower. So whatever thickness of sand you're expecting, it is not always resolved on the seismic data. That is number one. The second is the geophysics, the rock physics part of it. I mean, whatever you do, once you are from class 3 domain, AVO domain, into class 2, and then in between class 2 and class 1, then you are in an area where you need to do a lot of DHI studies, simple AVO work will not do. I'll touch upon a little bit when I come to technology part of it, that, you know, and I should go to the next slide. Uh, so, so basically, I mean, in the new technology areas, especially, for example, FWI. So in the left, you can see the velocity from full waveform inversion, and on the right, you can see the pressure stratigraphy, as we call it, from the similar data. So you can see the resolution, the way it has increased. So this kind of new technology inputs can change the way you look at the vintage data also, not just acquiring fresh data with new technology, but even looking at the vintage data in detail. Now, uh, broadband data has been in fashion, in vogue, and everybody is now doing broadband acquisition and processing. Uh, I have a personal experience that, you should look at the technology by querying the technology and whether it is suitable to your geology or not. I'm not saying broadband is bad or good. I'm just saying that we had an experience that the technology was actually, I won't say playing havoc, but it was kind of compromising the way we looked at the geology in that area. So basically, what I'm trying to say that even beyond broadband, now people are talking about increasing the frequency content of the data through deep learning, for example. And there is a concept of sparsity. Now, in I won't say which part of the world, but in India itself, people are working. And sparsity, the technology comes in from signal processing, actually, which geophysicists are using now. So there is a collaboration between engineers and geophysicists, especially in Indian Institute of Science, Bangalore. And they are working on how to increase the frequency of the data. So let's say you have, when you acquire data, you have certain signals in only certain part of the data. Now, how you use those signals in certain part of the data and populate it in other parts of the data. So I'm not just talking about feathering of the data when you acquire, but even otherwise also. So this is upcoming technology, and we are actually actively working in this area in-house, and then talking to concerned vendors who are working in this area. So this will change the way you look at the same seismic data, especially when you're talking of DHI below 3,000 or 3,500 meters of water, burial depth. Biogenic model, I want to mention briefly that, in deep waters, any biogenic gas that will be generated will be converted into hydrates, right? So the pressure temperature condition is such that it will be converted into hydrates. Now, hydrate, when it is converted to hydrate, that means the gas is enriched. You have a lot of volumes of gas trapped in the hydrate. With the same concept, when it further buries down, Mr. Shah, let me know if I'm exceeding time. It buries further, then it destabilizes, and then remigrates and goes to locales like where you have entrapment situation and you have good sands. So this model we have published long back. Many people agree, many people don't, but we carry this model to basically, any new area that we go, what is the burial history of the area? That has to be done in detail. And what will be the time at which hydrate destabilization will occur? And at that point in time, what are the locales, right locales, sand deposition has taken place? And, so that is a model. So any further input to that in terms of, basin modeling approach or detailed basin modeling will help that model to further, understand how the molecules of the gas they migrate once they leave the source rock or the kitchen area. Yesterday, I think there was a mention from Vinay Malhotra from SLB about open hole DST kind of a tool. Again, if you need a policy change. Now, as of now, we know that you need to do a DST and flow the gas to the surface to actually, you know, uh, what do you call it, that, I mean, give a discovery notification or go ahead with the discovery. Now, tools like these, although they are there, they have certain limitations, I understand. So, so basically, I mean, whether policy can support these kind of tools, and you can do away with DST. So that is where I'm coming from. So that will help not just in reducing rig time, but also reducing the carbon footprint. Deep learning areas, I mentioned, already discussed about frequency enhancement, but detection and pseudo seismic inversion. Those are again developing areas for reservoir characterization. So, I mean, list is long, but what I'm trying to say that technology can help us query the same data and understand the geology better. Thank you, and I'll be available to answer questions.